As you may already know, in HTTP, there are servers which hold data. There are clients which make requests to get that data. So now if we look inside a server, the way most of these things are implemented is that the request always passes through a multiplexer. A multiplexer is a special piece of code that looks at the request, the method, and other data to send it to correct handlers. So it looks at the request, looks at all the metadata around the request, and then decides which handler to send this data to. Now, in more complicated servers, when you have common actions that need to be done before sending data to a handler, for example, logging the request, making a trace of the request, modifying the headers, etc., we use a special piece of code called middleware to do this. So in this video, we're going to look at what a middleware is and how you can use it in your Golang projects. So I'm going to start with a boilerplate Golang project. So here I actually have a main.go file, which is package main. And you have the main function, and I have one simple HTTP server. Now here for the HTTP server, I'm setting the address as localhost 8080, and I also like to set some timeouts. So in this case, it's just 10 seconds. And then what I'm going to do is use this server and then run the listen and serve function to run our HTTP server. It returns an error and I handle the error. So now what we can do is that this HTTP server actually needs a handler to handle HTTP methods. So I'm going to, before that, what I will do is to create a multiplexer which multiplexes HTTP requests. So I'm going to use the default http.new serve mux. And this mux is a new serve mux. And what I'm going to do is write a comment saying mux is a request multiplexer. And now I can use this to multiplex our requests. So we're going to use the handle func function, which has two options, and you need to set the pattern which you want to handle and the function that then handles requests for that pattern. So this handler has a specific format, which we will talk about pretty soon. So what I'm going to do is to define the handlers. So the first would be a handle func that handles the root path, and the arguments should be these two specific arguments, and it does not have any return values. Before that, let's add a comment. Handle root handles the slash or the root path. This is also called index. And this requires these two arguments, as I mentioned. So those are the R and the W. So we don't have that here, and we can set that. So it's the response writer and the request. And here you can just do something like write header and write. You can do write header and use HTTP status codes. So I'm going to set it to, let's say, HTTP status OK. We can just use the predefined value for us and write a response that can be read. You can say something like it's a byte. So let's encapsulate a string in the byte stream and say hello, and say hello from root. And now what you can do is just make a copy and handle the other path. Let's say, for example, users, and handle users handles the users prefix. And now we can just use the same structure, but just say, change a few things here. Let's say we change this to hello users, and also change the type to status accepted or HTTP 202, just to give a difference between the two requests. And that is correct, it's 202. And now you handle the users route here. And these are our two HTTP handlers, and they need the specific two inputs, the response writer and the request. And now we can use this in our mux handle func. So the pattern here is slash, and that will be handled by the handle root. And the next one, of course, is the slash users pattern. And that will be handled by handle users. Since we have the both of these, now the mux can be used as the handler to the HTTP server. So we will do just that. And now we have a HTTP serve mux, which handles two routes, the index and the users. And for the index, you use the handle root function. We just return a status OK and some response. And same with handle users, a different status code and a different response, just to differentiate between the two. So now what I can do is to run this HTTP server. For that, I'm going to switch into my terminal and say, go run main.go. And right now the HTTP server is running, but I don't have any feedback. So what we can do is just add a log line here and say log.print, let's say printf, and use start server, and then let's say the address of the server, and that comes from the server.addr or address. And that looks good. So let's stop this now and run it again. And now I have some feedback that the server has started, which is pretty good. And that all works pretty well. That's your basic HTTP server. And now in another terminal, I'm going to actually request this HTTP server from as a client. So I'm going to use curl and do something like curl HTTP localhost 8080, and you get the root path. You can see I have not mentioned a path here, but these are equivalent, so you still get the root. And now what I can do is use the users path to get hello users. So that all looks good, and our basic HTTP wiring works. So now back in my code, let's say I want to log the request in both my requests. So I just want to log the request that is coming in from the client. So I can do something like log.printf, and we could print a few things. For example, the request received as an example, and we can also print the URI on which we received this request. So use r.request URI, and let's also add a new line there. And after that, we can just copy this and then put it in the handle users function. So we will be logging both the requests. And let's run this now. So if I go here, I'm going to make a copy of this so that I can have the server and the client running on the same window. It's easier to demonstrate. So I go like this, and let me clear some things. Okay, so now if I go here and run this, go run main.go, this is bound already. I see the problem. I'm already running this in another terminal, so I will stop that for a moment and close this one. And now if I run it, that works. And let me run these requests again. Localhost 8080 / hello root. And as you see, we have logged this in our logger, and that comes from one of these loggers. And if you try the users, you also see that this works. So for this simple set of code, you of course are just repeating the same log lines in multiple functions. This is okay for small pieces of code, but when you have larger pieces, this becomes a bit difficult to maintain. So we're going to do this in a much better way. So first, let's define what a handle function is. So a handle function, as I mentioned before, is a HTTP handler function. What basically that means is that there is a standard format for an HTTP handler function in Golang. So this is a simple shorthand to define easier functions to handle. And so the standard is something like this. So I'm going to call it handle func is a function that has no return values and takes 2 arguments. And the first argument is the HTTP response writer. The second one is the HTTP request. Now with the shorthand, you can then define something that's a bit more complex. So let's write down some comments about a general middleware construct. So a middleware is basically a function that takes in a handler and it returns another of these handle functions. So this gives us full flexibility to play around with these handle functions. So the handle functions here are of 2 types. The first one is actually the inner or the next function, which means that it's a second function rather. And this is the first one that is returned. So what happens here is that when you run the middleware, the first handle function, which is in the return, is called, and then it's wrapping the second one, which will then read or modify the data and then return the second request. This becomes complicated right now, but we will very soon see how this works. It's actually very simple. So what I'm going to do is to define something called a log middleware, a log function. So it's a middleware function that logs the request. We're going to replace the hard coding that we just did in the handlers. So log middleware uses this format. So let's use it like this. next or second would be the inner handle func. The outer one is just a handle func. And now we return this handle func, which means we have to return a function. So the function is something like this. We're just recreating the function skeleton, and that compiles. And what we do now is that within the return function, we are now going to do some things like log, for example, and we can just copy the logging from here. And once the logging is completed in the outer handle func, because we are returning it, we are going to run this function, which is the inner handle func. So we just say here next. So we're running the next handler and say w, r, and we pass the arguments to that. So this looks a bit complicated, but it's actually really, really simple. So the return handle func is first run. The request is logged because you're running that. And then after the request is logged, you're gonna call the next handler, which is going to be handle root or handle users. And the second handle func is the next, is the same concept here. And that's going to be one of these HTTP handlers. So I see there's a mistake. I'm going to fix the spelling here. Okay. So now what I can do is call this log middleware. The way to do this is actually to first call log middleware here. And you can do something like log middleware. And the argument to that is the handle root function, because you're expecting a handle func and returning a handle func. And handle root satisfies the handle func interface. And now you can do similar to log middleware in the next. So that looks pretty good. And what happens here is that you first come to the log middleware, you log the value first, and then you call the next. And in each of the cases, the next function is either handle root or the next function is handle users. So first call log middleware, log something, and then call next, which is handle users. Actually quite pretty simple, but then once you do this a few times, you will get a hang of this. And what this does is that it prevents repetition. So now let's run this. We are expecting to see if the same result is there. So if you run root, of course you print it. And if you run, let's say, the users here, you print that again. So we're getting the same result, but the code that we've used is quite different. So there you go. That's probably one of the simplest middlewares in Golang.